By the end of this video, you'll understand how to turn three-sum into a two-sum problem, and why sorting helps us avoid duplicate answers, and how to use two pointers to solve it efficiently. Let's begin. Now let's see the problem. The three-sum problem asks us to find all groups of three numbers in an array that add up to. We need to find all possible triplets that sum to 0. And we can't use the same element twice. And we can't have duplicate triplets in our answer. And these numbers in each triplet should be in ascending order. Now here is the key insight. We can turn three-sum into two-sum. Let's think about it. If we pick one number first, let's call it x. Then finding two other numbers that sum to minus x. See, it's just two-sum problem. But we need to handle duplicates. Now, this is where sorting helps us. If we sort the array first, then we can easily skip duplicate numbers. And we can use two pointers instead of a hash map. Remember our two-sum 2, this problem which I have previously made a video about it. See that yourself. Let's see how sorting will help us with this. -1, -1, -4, 0, 1, 2. And after sorting, it became -4, -1, -1, 0, 1, 2. Now, duplicates are next to each other, and we can use two pointers because it's sorted. Let's say we fix this -4. So our problem becomes we will find two numbers in this array that add up to 4. So we use our two-pointer technique. Let's say left here, right here. And if the sum of left and right is larger than our target, we need to move the right pointer left. And if the sum is smaller, we move the pointer to right. And here is how we implement this smart approach. First, let's create our result. We initialize it to an empty array list, and we sort array first. This is the key. Then we start to pick the first number. We're using a for loop here. Our for loop using the index I starts from the first, and it ends in nums length -2 because we have to leave 2 rooms to create a triplet. And now we're using two pointers to the rest of two numbers. Left pointer points to I plus 1, and right pointer points to the last number. And while these two numbers, while they don't meet, what we're gonna do is we calculate the sum of these three numbers. And if they add up to 0, And we know that we found our triplet. Let's put it in our result. And else if our sum is too large, and now there is an important case. Since that we have found our triplet, let's say our array looks like this: -2, -2, -1, 1, 2, 2. And if we want to find two numbers that add up to 0, and our left is here, and our right is here. So obviously, when we find our pair, which is this one and this one, what we're gonna do? We move our left pointer to right, but we skip everything that is the same as our previous elements. So we will skip this -2 and we jump directly to this to avoid any duplicates. And the same reason for right. So right will skip this, left will skip this. So now they become here. Left points to next element that is not -2, and right points to next element that is not 2. So here we skip duplicates for second number. So if the elements points to left is still equals to next element, we keep moving our left pointer. Same reason, we skip duplicates for third number. So if points to right equals to right -1, we keep make right pointer go left. And when it finishes, it means left and right points to a new number that is not the number that they previously points to. And here is it. And let's see another case. If our sum is too small, it means that our sum too small, so we need bigger numbers. We move our left pointer to right. And the last case, our sum is too big, so we need smaller numbers. And here is it. Let's try our result. See, we get a wrong answer here. Let's see why. See our output. We have 0, -1, 0, 1, -1, 0, 1. So we have a duplicate output. And why? Let's take this for an example. This is our input case. After sorting, it became -4, -1, -1, 0, 1, 2. And when our I is at this position, we are actually looking for two numbers that in this array that add up to 1. So what are these results? There are two results: 0, 1, and -1, 2. And when we fix here, the second -1, we are actually looking at here, this array. we are looking for two numbers that add up to 1, and there is a 0, 1. So this one and this one, they are duplicate. So what we're gonna do is, in this iteration, we need to jump every number that is duplicate. So after we see the first -1, we should jump every -1 that after it. So we skip this one, we jump directly to 0 and we start over. Now let's modify our code. Here we need to skip duplicates for the first number. So if nums I equals to the number that after it, we continue. And because here we have I minus 1, so we must check I is larger than 0. And let's check our results. And let's submit our answer. You see here, we only took 31 milliseconds